This is AP Pre-Calculus. We're on worksheet B for topic 1.11, polynomial and rational functions. In numbers 1 through 6, all we need to do is determine if we have a horizontal asymptote, slant asymptote, or neither. So we're essentially just comparing the largest power. We can ignore all the small things in these questions. So cross off all the small things. I'm looking at the degree, power of 2, power of 2. Whenever you have a matching degree, you'll have a horizontal asymptote. Horizontal asymptote. In number 2, again, we're crossing off all the small things. They're trying to trick us, and they put some of the small things at the very end. So make sure that you don't accidentally cross off the sign. I don't think it matters for this type of question, but if it asked exactly what type of horizontal asymptote we had, then it would matter. Notice that we have a power of 1 and then a power of 2. Whenever the numerator exceeds the denominator by just 1, in this case like 2 versus 1, that is going to be a slant asymptote. So we're going to say, this one, we have pen, yep, it's going to be a slant asymptote. In number 3, again, cross off all the small things, and we have a power of 3 versus a power of 1. This one exceeds by 2. If it had exceeded by 1, then we would have had a slant, so this one will be neither. In number 4, crossing off all the small things, just being careful I don't cross off something that's accidentally larger than the leading term. We have a power of 4 and a power of 3. We're one bigger on the top than the bottom, therefore this is going to be a slant asymptote. In number 5, the small things are crossed off, and I have a power of 2 and a power of 3. So the bottom wins. Whenever the bottom wins for our top-bottom rules, we have an answer of 0, and 0 is a horizontal asymptote. So bottom winning is always a horizontal asymptote. All right, and lastly, at number 6, oh, they didn't multiply together for us. So again, crossing off all the small things before I even do my multiplication will mean I have, in the bottom, I'll have an x to the power of 3. In the top, I'll have, remember that this squared gets applied to this x, so it's going to be x squared times 3x squared, which is going to be a 3x to the power of 4. The power of 4 and power of 3 are going to be the ones I'm looking at. 4 is bigger than 3 by 1, so this is going to be a slant asymptote. Slant asymptote. Excellent. And then we move on to 7, 8, 9, and 10. These are the last 4 questions on this worksheet. There is no backside, but we have to use long division. It specifically asks us to use long division to find the equation of the slant asymptote. I think I'm going to do long division on 7 and 9, and I want to do the reverse area or the reverse rectangular method in 8 and 10, just so that I can practice both methods and see which one I like more. All right, so in number 7, let's do long division. So I'm trying to find how much x squared minus 6x plus 7 go into, or how many times x minus 1 rather goes into that x squared minus 6x plus 7. And here's how I do that. So I first think, what do I multiply? What do I multiply by this x to get x squared? And the answer is x times x is x squared. So I'm going to put that x above the matching term x. And I'm going to do the multiplication. Okay, x times x is x squared. And x times this negative 1 is a negative x. And I'm going to subtract this entire term from the term up above, and you'll see that those two cancel out, and I'm left with, oh, be careful here. So I have a negative 6 minus a negative x. These double negatives are going to become positive, and I'm really going to be changing the sign from a negative and then positive. Those are opposite signs, I should say. So this is going to be a negative 5x. Be careful with your signs. Bring down the plus 7, and again, ask yourself the question, what number times x gives us a negative 5x? And the answer here is a negative 5. And when I do that, I'm going to get a negative 5x when I multiply our negative 5 by the x. And then again, negative 5 times negative 1 is a positive 5. Positive 5. I'm going to subtract that entire term from the term above. And I don't think it's really necessary to do this because right now we're just calculating the remainder, which we don't care about. But just to be thorough, I'm going to subtract, and I do indeed cross these off. 7 minus 5 is 2, so the remainder here is 2, but I don't think I ever need to worry about that. In the next, in problem number 9, as soon as I figure out this number right here, I'm just going to stop the problem and say, okay, there's the answer, x minus 5. So The equation for our slant asymptote in this case is going to be y is equal to x minus 5. Moving on to number 8, let's see how fast we can do an area model for number 8. So an area model, again, I'm going to have something that looks like a rectangle, and I have an x plus 3 on the side, and I'm going to have as many columns as it takes. I'm going to guess it'll probably take only 2, but I'll give myself 3 just in case. And I have 2 of these rows, so I'm going to go ahead and make my rows like so. Thank you. And I know that the area inside of here is going to add up to 2x squared minus x-ish. I'll see how well I can do that. I know that 2x squared has to go in the top right. And then what number times x is 2x squared? Well, 2x. And then if this number is 2x, I'm going to multiply 2x by 3 to figure out this value right here, which is going to be a 6x. And I know that diagonals will always have the same term type, so this is going to be an x. Therefore, this is also going to be an x. And these two x's have to add up to that x. So what number plus 6 adds up to a negative 1? And the answer is negative 7. If that number is negative 7, then I'm going to ask myself, what number times x is negative 7x? And the answer here is negative 7. And I could keep going with this and try to find remainders, but again, I only really care about that. So I'm going to go ahead and stop this prematurely and say our answer is going to be y is equal to 2x minus 7. In number 9, I want to go back to using long division. It is a larger problem. And just as a note, I'm wondering if it does it. No, it does. Oh, it kind of does it in number 10. Number 10, we want to be careful because we skip the power. Notice that we go down from a power of 3, power of 2, power of... where'd the power of 1 go? This is a power of 1 right here. It's hidden, and then the power of 0 is this 1 right here. So just be careful to give placeholders whenever you're skipping values. That's the only time that we skip values in number 10. In number 9, though, we're going to do long division. So we're going to say, how many times does this x squared minus 2x plus 5 go into this x cubed minus 4x squared plus 3x minus 1. Oh boy, here we go. So first I need to make sure that that term and that term match. So what number times x squared is x cubed? And the answer is nice and easy, it's an x. And since that term is an x, I'm going to put my answer right here of x. So I need to multiply this x by all 3 of these things. Here we go. X times x squared is an x cubed. X times negative 2x is a negative 2x squared, and then x times a 5 is a 5x. It's going to be positive 5x. And that entire trinomial is going to be subtracted from the term above, and we're going to cancel out the first one. What do I have here? I have a negative 4x squared minus a negative, so I'm really adding a 2x squared, and that's going to be a negative 2x squared. So we're going to have a negative 2x squared. And then 3x minus a 5x is a negative 2x. 2x. Bring down the minus 1. I don't think we really need to bring it down because it doesn't really matter. I'm just trying to determine what number here multiplied by x squared gives me a negative 2x squared. And the answer I think is pretty easy, is negative 2. So if I write down minus 2, I'm really done with the problem. I could show you that the negative 2 times x squared is negative 2x squared. A bunch of things here will not cancel out, and that doesn't really matter because the rest of this is going to be a remainder that I don't care about. So my answer is right there. It's x minus 2, and I can say my equation is y equals x minus 2. My answer box. Have I been boxing my answers up above? I don't know if I have. Box that one. Box that one. All right, and in number 10, true to my word, I'm going to do an area model or a rectangular model in reverse to do my division. And here I go. This is going to be a little bit large, and I'm in a car, so it's a little bit crooked. There's going to be 3 rows here because there's going to be 3 things that I'm dividing by. I'm dividing by an x squared, I'm dividing by a plus x, and I'm dividing by a plus 1. And the area inside of here needs to add up to 2x cubed minus x squared, more or less. So 2x cubed, the largest term, always goes in the top left. And I say, okay, this term is 2x cubed. And I ask myself, what number times x squared is 2x cubed? Well, I need another x to get up a power, so this number up here has to be an x, and the coefficient has to be a 2. And then I multiply all the way down. 2x times x is 2x squared. 2x squared. 2x times this 1 is 2x. 2x. And all of these diagonals are going to have to add up to the term that I'm hoping to get. So this is an x squared, this is an x, and this is just a nothing, which is a constant number. All right, these x squared terms should add up to a negative x squared. 2 plus what adds up to negative 1? The answer here is negative 3. If this number is a negative 3, then what number times x squared gives me a negative 3x squared? The answer is negative 3 times x squared is a negative 3x squared. If this number is negative 3, technically I'd multiply all the way down, but that's all I really need for my problem, and I can say my answer is y is equal to 2x minus 3, stopping the problem whenever I get the right amount of information that I need. All right, and that was a quick worksheet B for topic 1.11 for equivalent representations of polynomial and rational functions for AP pre-calculus. There's the entire worksheet in all its glory. Thank you for watching.